Okay, for this video we have this problem, U-substitutions and the fact that a circle of radius r has area of pi r squared. And we're going to do that to evaluate the interval. So we need to rewrite this. Substitutions, they say. Well, let's see if we can rewrite this into something we can recognize. So the main thing they're giving us, and there's other ways to do this, but the instructions are to use this approach. So let's do this. So we got u, let it equal, let u equal to sine of x. So du would equal the derivative of sine will be cosine of x dx. And now since we're going to change the variable here, we change the limits of integration also. We're starting off with the variable x. So we're going to have here x is equal to minus pi over 2, the lower limit. So we replace the x by minus pi over 2 here. Sine of minus pi over 2 will give us that u is equal to negative 1. Now if x is equal to pi over 2, this will imply then the sine of pi over 2 is 1, so this implies u is equal to 1. So let's rewrite this integral in terms of what we have here, this substitution. So first we substitute the limits of integration. So instead of minus pi over 2, we get a negative 1 as the lower limit. And instead of pi, instead of negative pi over 2, we get u equal to negative 1. And then instead of positive pi over 2, we get u is equal to 1. And then got the square root of 1 minus, and then the sine in this case is your u, so this will be u squared. And here the cosine of x dx, that's replaced by du. And then I could go further if I wanted to do it and not follow the instructions. I could use a trig substitution here and change the variable to theta. We could get the answer that they're asking for. But the instructions say to use the fact that a circle of radius r has area of pi r squared. So here's the situation then. Let's say this is 1 over here, and say negative 1 is over here. And I go 1 unit up here. Look at this as this way. Suppose I have the variable x squared, y squared. We set that equal to, in this case, 1 squared. That would be equal to 1 squared. That could be your r. R is equal to 1. That would be a circle of radius 1. So here we have it. So if I solve this for y squared and then take the square root, positive square root, because we have this above the x-axis. So this is the same thing as this, except instead of the variable x, I have it in variable u. So I know that the area of a circle of radius r is pi r squared. Well, you can see here that r is equal to 1. So that would be 1 squared times pi is going to be pi. Now this would give me the area of the entire circle. But the setup that we have here, we have the positive square root. So we want the area contained by the top half of the circle. That's this area right here. So pi is the area of the entire circle, but we want half the area because it's only the upper half here. We want this area right here. So we take half of that. So this is equal to pi over 2. And like I said, you can do it by just doing a direct trig substitution, and you can start with this part right here if you wanted to. So the answer is pi over 2. Thanks for watching. We'll see you next time.